Hey, hello everyone. I hope you guys are doing well. So, this video is my uh, would be fifth video on my YouTube channel. So, first, today I am going to solve a LeetCode problem. The problem number is 2037. Uh, the title of this problem is minimum number of moves to seat everyone. Okay. Uh, by reading the title, uh, something in comes in our mind. We have to arrange the seats and uh, to minimize moves. Okay. So let's go through the example. No, sorry, on description. There are n seats and n students in a room. Means the number of seats, whatever number of seats available in the room, uh, is equal to the number of students available in room. Okay. You are given an array seats of length n where seats I is the position of ith seat. Okay. You are also given the array students of length n where students j is the position of jth student. Okay. Now, first, let's try to understand the first part of the question. Then uh, uh, we will go to further part how what we have to do or something. What we have till now, just first go try to understand that. Okay. So we have a room. In the room, we have seats. Suppose you can consider as chair. Okay, and the students means how many students means students available in the room. Okay, so number of chairs and the number of students are equal. See here, seats and the length of seats and the length of student in a room are equal. Okay, so number of chair, first chair is at 3, means the position 3. Whatever, suppose that there are a row of there in the room there are arrange the chair in a row or something. The number of uh, the numbering system or something, you guys can figure out. So the seats, means the first chair is at position 3 and second seats is at position 1 and third seats is at position 5. But the student seat means the student are sit at the position 2, 7 and 4. Okay, I hope till now you guys understand. So what we have to do in this problem, you may perform the following move any number of times. Okay, increase or decrease the position of ith student by 1, that is moving the ith student from position x to x plus 1 or x minus 1. Okay, see, we can move any times to a student, not only one time. Move any number of times to seat uh, the student at the correct position. See, so as I am thinking the minimum number of moves. Okay, the return minimum number of moves required to move each student to a seat such that no two students are in the same seat. Okay, not that there are maybe not that there may be multiple seat or student in the same position at the beginning. Okay, cool. So I'm going to solve this problem by sorting the seats array and the students. This will be easier method to solve this problem. Okay, first let's sort the seat. Okay, sort. Also I'm going to sort students array. Okay. Forget this explanation. I'm going to solve by sorting. Here, they didn't sort. Okay. So what we have to count? We have to count the total number of moves in the row. Total moves. Okay. Zero. Total move is zero. And start. Okay. So first I am going to um, iterate the first. Let's write and then of series. Okay. See what I want to do. Where is the not? No, we have not, right? Yeah. See, after sorting of seats means after sorting of the chair. So we have chair at 1, 3, and 5. Okay. And student at the position means student sits at 2, 4, and 7. The question asked to us how many moves uh, performed to student to sit at the chair. We do not disturb the we do not need to disturb the position of seats. We can move student to the seat. Okay. See here, student sits at first student sits at position 2. We can move 2 to 1. Okay. The now students first student sits at correct no, correct position of chair. We have chair vacant at position 1. The second student it sits at position 4, but the empty chair is available at the position 3. So we can move 4 to 3, the second student. And the third student sits at position 7. We can move uh, 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 his to position 7 to sit the correct chair. Now, how many moves we perform? Uh, to sit first student, we perform one move. For the second student, one move. For the third student, two moves. 7 to 6, 6 to 5. So total moves is 1, 1, 2 to 4. See, in total there are 4 moves were used. Okay, the number are matching. For the second example also, you can see and so let's do one thing. So here I am going to run a loop in the range of the seats means how many whatever the length of the seats, the number of seats same as the number of students. Also we can do one thing, you can use the students, not a big deal. Okay, see, now I'm going to write a if condition. If seats seats I is less than So what we have to do? Yeah, if the uh, seats I means, see here we have not, right? Seats I, here seats I means seat 0 is 1 and student uh, 0 is 2. So if uh, uh, the 1 is greater than, here is 1 is less than 2, where is the greater? We don't have here. It's equal to total moves plus I minus precedence I. Okay. First, let me try to complete the statement, then I'm going to explain. Okay. No need to worry. This is very simple example. Also, you can see the tag is easy. So this is very easy. It's not a big. Just this side. Okay. See what here I did. If the seats means the position of IA seat is greater than the position of student at IA, means the seats is at higher position or student is at lower position. So what do we have to do? We have to minus the position of seats with the students of ith position. And in this case, if this case is not uh, means if the uh, once these statements become true, then we are going to perform this task. If this statement is false, means it at the reverse condition. If seats if position of ith seat is less than the position of ith student, we have here the example where the first student is at position 2, but the seat position is at 1, means student is at higher position. So what we have to do here, just to be subtract 2 minus 1. Same thing here I did, 2 minus 1. For the second student, 4 minus 3. See, 4 minus 3. Okay. For the third student, 7 minus 5. Let's consider a example where the uh, position of seat is at higher as compared to the student. Mm, See, in the second example, here after sorting this area, what we have 4, sorry, 1, 4, 5, and 9. Okay, means vacant chair available as at the position 1, 4, 5, and 9, and student sits at the position 1, 2, 3, and 6. Okay, see here the seat position for the first student we don't need to move anything because the first student sit at the correct position, because student position is at 1 and also see vacant seat as at 1. So he sits on the correct place. But for the second student, uh, a student sit at position 2, but the vacant seat is available at the position 4. Okay, so see here, seat position is at 4 and student sit at position 2. So we have to, I wrote this just to count the total moves or the add the total move. Seats position 4 minus student position 2. So we have 2 here. Okay, 2 and uh, 5 minus 3 is also 2. 2 plus 2 4 and 9 minus 6 is 3. So here we have to perform total number of moves is 7. See here is the 7. Also for the example 3, so we just return the total moves. The artist is accepted, passed. Just try to submit the program. Yeah, we are below average, so I need to worry about the time. I hope you guys are understand the program. What if you have any doubt, just uh, try to understand with the vacancy. Suppose do not consider this seat. Uh, think about the chair available at the position 3, 1 and 5, and but the students sit at the position 2, 7 and 4. How you can move the students so that there should be as minimum number of moves required to seat student at the correct number of position to the correct number of chair at position whatever the at position chair is vacant. Okay, if you guys have still doubts after uh, this description and we go through the example, just ask me in the comment. I will uh, upload a video or I will modify this video itself in detail with the writing by the pen on paper or something. Okay, I hope you guys like the detailed explanation and the solution of this problem. Thank you.